Assalamualaikum and hi everyone. We are from Group F for subject SMQ3043 Linear Programming. So today we would like to explain about our project, which is how linear selection impact food business success. Before that, we have 5 group members, which is me, Arisa Fizati Syairah binti Zulhaidi, Nurul Nadira binti Alias, Nurin Batrisha binti Azmi, Syazra binti Mansur, and lastly is Sul Ifah Nadira binti Muhammad Zulkiman. Now, let's look at project background. To keep it simple, Aboya Station was founded in 2015 by 28 years old entrepreneur Encik Amir Shafiq Adha. The name Aboya is a tribute to his father's legacy, and today they have 4 branches and we are focusing on their busy 16-hour operation at the Upsi KH Cafe. They are famous for 3 main dishes, which is burgers, ayam gepuk and char kway teow. Problem statement. Aboya Station operates a food business offering 3 main dishes, which is ayam gepuk, burgers and char kway teow, each giving a different profit, with 1.20 ringgit earned for every ayam gepuk, Rm 1 ringgit for each burger, and 3 ringgit for every char kway teow sold. In terms of cost, producing a serving of ayam gepuk requires 4.80 ringgit, while a burger costs 3 ringgit and char kway teow costs 4 ringgit. All of which must be managed within the daily budget limit of 1,431 ringgit. The preparation time for each dish also varies, where ayam gepuk takes 5 minutes, burger requires 2 minutes, and char kway teow takes 4 minutes. And the total operation time alone per day is limited to 960 minutes. Additionally, the availability, the chicken stock restricts the production of ayam gepuk to 54 units per day and char kway teow to 6 units, while burger require no chicken stock. Considering this cost, time and stock limitation, the bistro aims to determine the ideal quantity of each day to produce daily in order to maximize the total profit. Now, we need to list all the information in the table. The table below shows the amount of the time needed for each unit during the process preparation, cooking and serving. And then, we need to determine the data variables to represent the quantity of each dish produced daily. Let X1 represent the number of ayam gepuk produced per day, X2 represent the number of burgers produced per day, and X3 represent the number of char kway teow produced per day. These variables are the unknown that we need to determine in order to achieve the best outcome. After that, we need to use all the data and write FP model.
Next, I'm going to show you a step-by-step guide on how to use Lindo, which is one of the powerful software tools that we use to solve linear programming problems. So let's get started. The first thing or the first step that you need to do is input and insert your data. For the first step, you have to start by typing your objective function, like this example, and next you must type subject to and list all your constraints like C1, C2 and C3. The most important thing that you have to do is you must always end your coding with the word end. This will tell the software that your problem is complete. For the second step, you have to choose solve. Once your data is ready, it is time to find the solution. Look at the top menu bar and click on the solve tab. From the drop-down menu, simply click the first option, which is also called solve. After you click solve, a small box will pop up asking do range sensitivity analysis. Since we want to see the full details of how our variable can change, so please click yes to get the detailed result. For the fourth step, you will see the solver status window. This shows you that the status is optimal, meaning that Lindo has found the best possible answer. You can see the objective value here. Once you have confirmed it's finished, just click solve to see the full report. And for the last step, the report window will appear. This is where you will find your answer. Here is the objective function value, which is at the top is your final profit or cost. In this case, it is 490. There is also the variable value section that tells you the best quantity for X1, X2 and X3. We also label the optimality range and the feasibility range. And that's it. You have solved the FP problem using Lindo.
Next, for the change in right-hand side scenario, Aboya Station had to increase the daily operating time from 960 minutes to 965 minutes to address the increase on customer demand and ensure they could produce more dishes without compromising on quality. With the additional time, then you can maximize production, especially for products that require longer preparation time, such as ayam gepuk, char kway teow, in line the objective of meeting the growing demand. And so we put this value into the Lindo top section shows the model before the change, while the bottom section is after inserting the new value. Especially, we modified constraint to increase the operation time from 960 minutes to 965 minutes. The difference then is 5 minutes, which fall within the allowable range between negative 920 and 7.333. Based on the output, we can observe a specific change in the decision variable. Variable x2 increased from 460 to 462.50, while the other variable remains the same. Consequently, this impacts our total profit. The objective function value, or z, increased from 490 to 492.50. This new z value is derived using the dual price. Since the dual price is 0.5 and we increase the time by 5 minutes, the calculation adds 2.5 to the original profit. Therefore, we archive the new z value of 492.50. The modification of the right-hand side by increasing the operation time alter the optimal solution value, resulting in a new optimal solution and increased objective function value of RM492.50.
Next is change in objective function. The original profit for ayam kepok is RM1.20, burger is for RM1, and also char kway teow is RM3. However, due to an increase in customer demand and improved sales performance, the management decides to raise the profit, which is from RM1 profit of burger to RM1.50 per unit. The different change for burger, which is D2, is still inside the range, the range is from negative infinity to 10.3. There is also changes in variable value, which is the original value for S2 is RM460, but after changes, it become decreasing and changed into RM131.43. Now let's take a look at the left side, which is our original objective function. As we can see here at Lindo, the original objective function value, which is Z, is RM490. But after we make a change in profit of burger, we got the objective function value for RM227.14, which is decreasing. So in conclusion, the modification of the objective coefficient altered the optimal basis, resulting in a new optimal solution and a reduced objective function value of RM227.40.
The project demonstrates Abuya Station challenge of maximizing daily profit with cost, time and chicken stock limits. Each menu differs in terms of profitability, cost and preparation time, so production decisions need to be made strategically. The problem-based learning approach helps us understand real problems, analyze constraints and find practical solutions while improving critical thinking and decision-making skills. Suggestions for improvement include focusing on the most profitable menus with cost and time efficient, managing chicken stock better, and using optimization method to increase the company's profitability.